Hi, I'm Liz Sneddon. Let's have a look at how we can calculate the mean or standard deviation for our normal distributions. So the key thing is that we need to have enough information to be able to work this out. And then we're literally reverse engineering it, if you like. So what we've got in this example is we have our weights of backpacks, and they're found to be normally distributed with a standard deviation of 0.6 kg. So what that tells me is my mean here in the middle, I don't know what that mean is, and that's what we need to work out. We do know that the standard deviation is 0.6 kg. Now if I look at the next sentence, it says if the probability a backpack weighs more than 4 kilos is 0.0179, so that's quite a small, that's only 1.8%. So what it's saying is from this value here of 4.0 kg, the area above that is 0.0179. So that's the probability of being more than 4 kilos. So we've got some more information in terms of a probability and an x value. So what we're going to do is we are going to first of all use that to find the equivalent z value. So that's what we want to find, is the equivalent z value. Once we know that equivalent z value, we then have a formula, z equals x minus the mean over the standard deviation, and that formula converts between these two x and z distributions. So with the z distribution, I know that it has a mean of 0 and a standard deviation of 1. So once I find this equivalent z value here, I can then use this information to work out what the mean would be. So that's the process that I'm going to go through. So we're going to start by using that information. So we've got a probability, we've got an x value. So we want to now find the equivalent z value. So let's go to our graphics calculator. Oh, not that one. This one. There we go. And I want to do distributions, F5, normal distribution, F1, and inverse normal, F3. Now what I'm going to do with my normal distributions, I know my z distribution has a standard deviation of 1 and a mean of 0. So I'm going to put those into my calculator. The probability that we've been given, that was on the right hand side, it was that top little tail. So I'm going to change this to the right tail, F2, so that's a right tail, and the area was 0.0179. So when I go through and find it, this, I know it says x there, just that's the default. This is now actually my z value. So this is the z value. Remember we put in that had a mean of 0 and a standard deviation of 1. So that's my z value distributions. And for that probability, this is its equivalent z value, 2.099. So let me go back to here. So that equivalent z value there is 2.099. So that value there is that z value that's equivalent to the 4 kilos. Now I can use that 4 kilos, this z value, and substitute these values into the calculation here. I can also substitute in my standard deviation and then rearrange to find the mean. So that's what we're going to do now. So there's my formula, z equals x minus the mean over the standard deviation. My z value was 2.099. And the x value that it was equivalent to is 4.0 kilos. Minus, well, I don't know what the mean is, but I did know that the standard deviation was 0.6 kilos. So now I need to do some rearranging. I want to get rid of this divided by, that fraction line. The opposite of dividing is times. So 2.099 times 0.6 is equal to 4 take away the mean. And I'm going to grab my little calculator and I'm going to say 2.099 times 0.6 is equal to 1.2594. And that's equal to 4 minus the mean. So I was just simplifying that side. Now what I want to do is I'm trying to get the mean by itself because that's what I'm trying to solve. So I'm going to take that value of 4 and I'm going to move that to the other side. So if it's positive on the right hand side of the equals, when I move it across it'll become negative. So I'm going to get 1.2594 take away 4 is equal to minus the mean. So that negative has to stay with the mean. So when I subtract that, come up here, that's going to become negative 2.7406 is equal to minus the mean. Now if I multiply both sides by -1, then that will get rid of the negatives. So then I get 2.7406 is equal to the mean, and it doesn't matter which way round I write that. I'm just going to round that to 2 decimal places. And that is the number of kilograms. So the mean for this distribution, where I have that probability, that gives me a mean of 2.74 kg. Let's have a look at a second example. So in this one, we've been given the mean of 3.3 kilos. So we can put that mean in there. So there's our mean of 3.3 kilos. We need to find the standard deviation, so we don't know that yet. And if the probability of backpack weighing between 2.7 and 3.3 kilos is 0.4332. Okay, so let me take those two weights, 2.7 kilos and 3.3 kilos. So let's put this in here, 2.7 kilos, and there's my 3.3. So the area between that, so that's the probability that it's referring to. Backpack weighing between 2.7 and 3.3. That probability is 0.4332. Okay, so I want to find the equivalent Z value. So I know the equivalent Z value here, that has a mean of 0, standard deviation of 1. So the mean of 3.3 kilos is equivalent to the mean of 0. So I know that equivalent point. I need to find the equivalent point for the 2.7. So I need to find this equivalent. Okay, now to do this, this is where we've got to do one more step. And what we need to do is we need to work out the opposite bit. So let me just change to a different colour. If the red probability that I've shaded in there is 0.4332, I need to figure out what this little tail here is. Remember in our calculator we usually gave it the tail values or the centre values. So we need to work out what that tail on the left there is. So from the mean, half of the data is below the mean. That's the definition of what a mean is. 50% of the data is below. So to find this probability, if I go 0.5, take away 0.4332, that will tell me how big this little piece down the bottom here is. And that works out to be 0.0668. So now that I've got that probability, now I can go to my graphics calculator. Okay, and so we've got the tail on the left hand side now, so F1 to change that, and the probability, we just calculated that, was 0.0668, and that gives me a Z value of -1.5. Okay. So that Z value there is equal to -1.5. So I've found the equivalent X and Z values. So in that formula, which we're going to use in a moment, Z equals X minus the mean over the standard deviation, we now know what the Z value is. We know what our equivalent X value is, 2.7. We know what our mean is, 3.3, but we don't know what the standard deviation is. But we've got now enough information to be able to solve that. So that's what we are now going to do. So our Z value is negative 1.5. The X value was 2.7 kilos minus the mean of 3.3 divided by the standard deviation, which we're going to work out. Okay, so let's get rid of this divided by standard deviation, so that fraction line. I'm going to take the opposite of dividing is times, so I'm going to move the standard deviation, negative 1.5 times the standard deviation equals 2.7 minus 3.3. Now if I do 2.7 take away 3.3, then that's going to give me negative 0.6. So that's what I'm going to do on my next line. Just going to tidy that up. That's going to be negative 0.6. Okay, now I want the standard deviation by itself, so I want to get rid of this times negative 1.5. The opposite of multiplying is dividing. So that's going to become the standard deviation is equal to negative 0.6 divided by negative 1.5. I'll put that into my calculator, and that's going to give me a value of 0.4. So there is my standard deviation, 0.4 kilos. Thanks for watching.